Alright guys, in our last lesson we covered depreciation, and now we're going to be looking at reducing balance loans. Basically what this means is you have a loan, car loan, mortgage, something like that, and you're making regular repayments, and that is reducing the balance of the loan, which also is reducing the interest that you owe. We have two formulas we need to be aware of. So basically how the questions are going to work that we're going to be doing in this unit is you're going to be given probably this, what the loan payment should be, and then you're going to have to make some calculations. But this kind of makes sense intuitively. The total amount that you pay back here is equal to the amount that you pay in each repayment times the number of repayments that there are. Or another way of looking at it is the total amount that you pay back on the loan is equal to the principal, the amount of the loan, plus the interest that you have to pay. So let's look at a question. This is the kind of question that you're going to get. You're going to be given a table of loan repayments. These values here are all the amount that the repayment is monthly. So we're going to calculate the amount of interest that's going to be paid on a $200,000 loan over 13 years. So the first thing we need to do is work out the total that gets paid, which equals the amount of the repayments the repayment amount times the number of repayments. Now, the repayment amount we need to read from the table. We have a $200,000 loan over 13 years. So the amount of the repayments is going to be this. And then we need to work out the number of repayments we pay back. So we pay monthly repayments for 13 years. So we have, this is 13 years, and then this is for 12 months every year. And that comes to a total amount for the loan of $445,536. Sorry, that was a bit of a tongue twister. Now, that's not what the question is asking us. We haven't completely finished yet. We need to calculate the amount of interest that was paid. Now, remember, we also had the formula, the total amount of the loan equals the principal plus the interest. And we are interested in finding the interest, so we're going to take the total of the loan and subtract the principal. So that is the total amount of the loan goes here, and then the principal is what we started with, 200,000. So that means the interest paid on this loan was 245,536. And that's the answer. Let's do another example. Oh, sorry. So here again we have a table showing the repayments. And we need to read the table, figure out the monthly repayments, and then calculate the total amount of the loan. So this table is a little bit less straightforward than the first one because we have, say, here for a 10-year loan at a 6% interest rate, we have repayments of $11.10 for every 1,000. So that's not really $11.10. It's going to need to be multiplied by 1,000, basically. So let's look at what Molly actually has to pay. She is planning to borrow $280,000 at 8% interest over 20 years. So we're going to be needing to follow the 8% and the 20 years. So this is going to be her monthly repayments for every 1,000 that she borrowed. So her repayments equal 836 times 280 because she borrowed 280,000. And that comes to $2,340.80. That's her monthly repayment. So the total, same as before. Total is the repayments times the number of repayments, which is $2,340.80 times, this time it's 20 years, but the repayments are monthly, so don't forget to add that times 12 in. So the total amount that she pays back on the loan is, if we put this in our calculator, now, the last question asks us to look at how much would she save if she paid the loan back over 15 years. So we need to essentially redo the calculations we just did. I don't have much room. I'm going to do this one over here. Okay, so her monthly repayments are going to be the new rate times the number of thousands that she borrowed. That calculation is the same. The answer is just slightly different. So now her repayments are higher, but if we look at the total amount she pays over the course of the loan here, we're actually going to find something quite interesting. So we take the amount of the repayments and we multiply it by the number of repayments. This time it's not 20 times 12, it's 15 times 12 because she's reduced the period of our loan to 15 years. So if we put this one in our calculator, we actually get 481,824. And as we can see, she's actually going to save quite a lot of money here. If we take the 20-year period and we subtract the 15-year period, she's going to save almost $80,000 over the whole course of her loan. Which is pretty significant. Going into some of the practical things about loans, this is something that is not really going to come into our questions that we're going to be answering in terms of calculations, but this is something that is just really helpful for you guys to know, that there are all kinds of fees and charges that are associated with having a loan, especially if the loan is a mortgage. because not only are there bank fees, but you also need to pay legal fees because you need a solicitor. But this is something that I really want to focus on here. Is we kind of saw it in our last example. This is a graph of the same loan at the same interest rate, but repaying it faster. The red line is repaying $500 a month, and the blue line is repaying $1,000 a month. So what you can see is one line dips a lot more sharply than the other, and basically the consequence of this line going straight down here is that choosing this method of repayment, you actually save significantly on the amount of interest you pay back. And that's what we saw in our example up here. By choosing to pay slightly more per month, but pay the loan off 15 years faster, this person was able to save $80,000, which is nearly 20% of the initial value of the loan. Alright, so you guys are going to have a couple questions to do from exercise 8B, and there aren't that many questions, so I'm just going to get you guys to do all of them. Thanks, guys.